Class, today's topic is the remainder theorem, but first what we're going to do is look at what we discussed last class, which is synthetic division. Let's start off with an example of 5x cubed plus 6x plus 8 over x plus 1. Now, if we remember from last class, we need to note that there is not an x squared here, so we're going to rewrite the problem and write an x squared in the equation in order to do our synthetic division. So what we're going to have is 5x cubed plus 0x squared, because 0 plus times x squared is going to equal 0, just like our original equation, plus 6x plus 8, all divided by x plus 1. Now, what we need to do is take the 0 out from this equation, so x plus 1 equals 0, then x will equal negative 1, because you're going to bring the negative 1 to each side. So we're going to have negative 1 on the outside of our box, and then we're going to box it, and then bring our 5 down, plus 0, plus 6, plus 8. And then what we do next, if you remember, we bring the 5 down, so we have a 5 at the bottom, and then we're going to multiply 5 by negative 1 and get negative 5. Now we add 0 plus negative 5 and we will get negative 5 again, and then we will put the negative 1 times negative 5 and we'll get positive 5. 5 plus 6 is 11, and then 11 times negative 1 is negative 11. So then our remainder is this last term, and it's going to equal negative 3. And our equation is now 5x squared minus 5x plus 11 with a remainder of negative 3. Now, if you remember from the topic, from me saying before that our next topic is the remainder theorem, we're going to be looking at the remainder. So let's look at the definition of the remainder theorem. The remainder theorem states that if you divide a polynomial f of x by a linear factor of the form x minus a, the remainder will equal f of a. So this pretty much states that if you have an equation, f of x, and it's divided in the form of x minus a, then the remainder will equal this number a plugged into your original equation f of x, and you will get f of a. So let's look at that. Here's an example. 5x cubed plus 6x plus 8 over x plus 1. So if we look back at our definition, we see that x minus a is what needs to be divided by, and here we have x plus 1, so this is going to change our plus 1 into a negative 1, because that will give us x minus a, which would be negative 1, and that gives us the plus, so it equals. So negative 1 is our a. And our theorem stated that our remainder will equal f of a. So I'm going to plug my a in for the x, so 5 times negative 1 cubed plus 6 times negative 1 plus 8 is going to equal our remainder. So we have 5 times negative 1 cubed is going to be 5 times negative 1, which equals negative 5, plus negative 6 plus 8. This is going to give us negative 11 plus 8, so negative 3, negative 5 plus negative 6 plus 8 is going to give us negative 11 plus 8, and that equals negative 3, which is our remainder. So let's compare. We found that in our synthetic division example, the remainder was negative 3. And note that it is the same exact equation. 5x cubed plus 6x plus 8 over x plus 1. 5x cubed plus 6x plus 8 over x plus 1. And we ended with the same remainder. So this theorem is going to give you a faster way to find the remainder of a function. Alright, and now for your homework, you guys are going to do these two problems. F of x equals 4x squared plus 3x minus 2 over x plus 2. Our second problem is going to be 3x to the fourth minus 2x squared plus 5x minus 1 over x minus 1. Notice that you do not have an x cubed here, so be sure you note that when you do your homework. And please turn this in tomorrow because it will be graded. Thanks, guys.